What's up, coders? Welcome back to the channel where we break down the toughest coding problem into easy to understand solution. Today we are tackling a classic dynamic programming challenge, finding the minimum path sum in a triangle array. By the end of this video, you'll not only understand the solution but also be ready to crush similar problems in your next coding interview. So let's dive in and decode the magic behind this challenge. Here's the challenge. You're given a triangle like this. Now, here's where it gets exciting. Most people try solving this problem from the top down, calculating all possible paths. But that's inefficient and messy. Instead, let's work from the bottom up. By solving smaller subproblems first, we'll have everything we need by the time we reach the top. This is the essence of dynamic programming. Let's code it in C# and see the magic unfold. Here we start by defining the triangle as the list of lists. Each sublist represents a row in the triangle. For example, this structure allows us to easily access each element row by row and column by column. It matches the triangle representation we are solving. Next, we call the minimum total function, passing the triangle as the input. This function is where all the logic to calculate the minimum sum happens. After the calculation, we print the result to the console to display the smallest path sum. Now we define the minimum total function. The core idea is to work from the bottom of the triangle to the top, solving smaller subproblem first. We begin at the second to last row. This is because the last row is used to calculate the minimum sum for the row above it. Here's the outer loop. It starts at the second to last row, triangle.count -2, and moves upward towards the top row, that is row greater than equal to 0. This loop ensures we processes each row in reverse order, working from the bottom up. Inside the outer loop, we have an inner loop that iterates through each column of the current row. This allows us to access element in the row which will update with the minimum path sum for that element. Here's the magic. For each element in the current row, triangle row call, we add the smaller of the two adjacent elements in the row below. Triangle row +1 call is the element directly below triangle row +1 call +1. Is the element that is diagonally below to the right. Using mat.min, we pick the smaller of these two and add it to the current element. This updates the current element with the minimum path sum leading from that position. Once the inner loop completes, the entire row is updated with the minimum sum for each of its elements. The outer loop moves up to the next row. Finally, after processing all rows, the top element of the triangle 0, 0, contains the minimum path sum for the entire triangle. We return this value as a result. So that's how you will solve the minimum path sum problem using dynamic programming in C#. It's all about flipping the perspective and working from the bottom up. If you found this helpful, don't forget to hit that like button, share this video with a fellow coder, and subscribe for more bite-sized explanation to tricky problems. Got a question? Drop it in the comments and I'll make sure to answer. Until next time, happy coding.